All right, so now we're recording. All right, so welcome to CSE 204. We're going to start talking about, finish off talking about conceptual database design. Let me go ahead and share my desktop here. Okay, so this is where we left off, was we're kind of the bird's eye view of conceptual database design. There's also some slides on the logical and the physical as well. We won't review over those because I'll reintroduce those when we talk about logical and when we talk about physical, because this is kind of just one slide that kind of says these are the 9 steps. These are the 9 steps that are involved in the conceptual database design overall step, the overall step 1. One of the things that you're going to notice, or if you don't notice, I'll point out, one of the things that you'll see as we start moving through these is that we are moving more and more towards a technical understanding of the database. Okay, so the conceptual database design, if you remember from last week, what I said was the output of the conceptual database design is an ER model, is an entity relationship diagram or model. And so that is something that you and I should be able to look at and be able to build a database, an actual physical database off of. But it's also useful for non-technological folks, right? For your managers, for your investors, for your users, some of your users, to be able to understand how the data fits together. So the diagram is helpful for technical and non-technical folks. So it's something that's useful for both types of people to be able to understand how the database operates. And it's the conceptual idea. It's the ideas behind the database, the ideas of what the database should look like. Then when we move into the logical database design, and you'll see what that looks like. Again, my hope is for us to start that today. What you'll see is that we will take that ER diagram that we built in the conceptual design phase, and we will take that diagram and we will build a database dictionary, a data dictionary off of that. So what you're going to see is the output of the logical database design. It's going to look a lot more technical. It's not going to be a diagram, a drawn diagram. And so it's going to be a lot more, it's going to be closer to SQL. Okay, it won't be SQL, but it will be closer to some of that. It'll be closer to what a database creation set of scripts might look like. Okay, and we'll see how that is. And if you've looked ahead to the logical design lectures, those slides are available on our website. If you have looked at those already, then you've seen kind of the output of that. You've seen what that is going to look like. Okay, and then finally, of course, the physical database design. It's not just the choosing of the server, although it is part of it. It's not just the what type of SQL or what kind of DBMS we're going to use. Are we going to use MySQL, Oracle, those things, or some of these NoSQL databases that some of the groups are using for their project. It's not just that, right? That's part of it, but it is also some of those scripts that we will use. It's one of those scripts it's a set of scripts that we'll use to create the different database objects as well. Okay, and we'll get into all that. We'll get into the physical design. So again, conceptual, useful for programmers, non-programmers alike. The ER diagram we get out of that. The logical phase. Primarily, programmers are going to see that output. They're going to be able to look through it and kind of understand it. Doesn't mean non-technical folks won't be able to, but they're going to like the model more. They're going to like the ER diagram a lot more. And then your physical database design is going to be primarily for your database developers, your DBAs, your DB your database administrators and your data administrators and your database programmers, people who write code, even if it's user interface code, but code that incorporates SQL or whatever as part of it. Okay. All right. So let's get down. Let's get down deep into this, how to build a conceptual data model. All right. So we need to be able to have all of our entities, all of our relationships, all of our attributes, and all these things defined. Okay, so our first step is going to be identify what types of things are entities. Now, if you remember, one of the things I mentioned before was that in general, if you look at a company or an organization's mission statement, what that will tell you is a lot of what they need, anything that they use within their organization for. It doesn't not just the database, it's lots of things that they use. And so generally speaking, you take a mission statement, you take other types of documentation, and you look for noun words. Now, noun words will end up being noun words will end up being one of two things usually. One is either an entity, or the other is possibly an attribute inside of an entity. And basically, the way to think about which one a certain noun might be would be, is it a major category that has lots of attributes to it that we are tracking, or is it just an attribute of a major category? Is it just part of a major category? So, like for example, if you were to say, just look at a shopping website, and you were to say, we want to keep track of our customers and the products that they have purchased. Now, basically, the two nouns that jump out at me from that sentence, from that statement, is customers and products, right? So I would look at that and say, okay, customer should be an entity, product should be an entity. Obviously, we need to look at more literature. We need to look at more documentation to determine some of the other entities that don't come out of just that one statement, right? But just out of that one statement, we can look and we can say, okay, customers and products, those should be categories. Those should be entities. Now, are the customers going to have attributes? Are the products going to have attributes? Absolutely. And we will get to that in just a moment. But we need to identify whether, if a sentence says something like, we want to track customer names and phone numbers, and to identify which products they have ordered or something like that, then now we've gotten into a situation, okay, names and phone numbers, part of a customer, right? They're the attributes of a customer. So even though they're nouns, also, we're going to look at those and we're going to say, no, those are not a major category of thing. That's not an entity. That's an attribute. Okay. So mainly we want to identify the types of things that we are tracking, that we are keeping data for. All right, and we'll identify those as entities. Then we need to see how they are related to each other. How do the entities relate to each other? So in that first example, the first thing I said was that a customer, we want to track customers and the products that they have purchased or ordered, right? So what we would see is that a customer and a product has a relationship, right? That when a customer orders a product, then we should have some type of entry in the database, okay? Hopefully you would recognize, if you kind of drew this diagram out, you would pretty quickly recognize that this is a type of many-to-many relationship, okay, where a customer can order many products and a product can be ordered by many customers. Now, it's possible that if by product we mean a specific one of a type of product, for example, If I were to say, it depends on how we define product. Do we define product as I'm just holding my phone in my hand, for example. Do we define product as the iPhone 7 and there's many of those that and a customer can order one of them? Or do we specifically say that a product is a particular iPhone 7 that has a particular IMEI number, that has a particular serial number, all of these things? And in which case, now suddenly that customer to the product relationship changes, doesn't it? Now, instead of being a many-to-many relationship, it becomes a one-to-many relationship, because now two customers, more than one customer, cannot order the same exact iPhone with the same serial number and IMEI number, right? Okay, so it becomes a little bit different depending on how we define what a product is. Okay, and what I'm getting at with that is something that you guys have heard me say more times than you can count, and you might be even getting tired of hearing me say it, but there is not just one right way to do things. And so we're not going to say that this is the right way to define what a product is. What we're going to say is, you know what, there's a couple different solutions, and depending on how we define product determines what type of relationship product has with customer, and know that how we define those things and how we do those things, there's trade-offs. There's pros and there's cons for each way of doing it. Okay. So we'll move on now to the next one, because like I said, I do want to try to get to logical, at least kind of surface introducing logical before the end of this lecture. But that's the idea. So far, we're identifying entities, those blocks, the boxes, the squares that we draw in the diagram, and then we're identifying the relationships. How are they related to each other? And now remember, just because two entities exist doesn't mean they have to have a relationship with each other. Okay, we'll get into some examples of that. What's called a redundant relationship. If two entities have a relationship with each other in our initial version of a diagram, but there's really no need for those two to have a relationship. Okay, all right, because redundant relationships can really kind of sometimes mess things up if we keep them around when they're not necessary. Okay, all right, so I've already talked a little bit about identifying attributes, right? So one thing we did talk about a long time ago, back before this whole quarantining thing became a thing. So we talked about that sometimes relationships can have attributes. One of the things that we will see is that generally the only relationships that have attributes are many-to-many relationships. And so we'll get into why that is when we talk about the logical database design. Okay, but for now, just know that attributes can exist with an entity. In fact, attributes should exist with an entity. If we're tracking something, if we are keeping information about our customers, if we're keeping information about our products, if we're keeping information about our students, about our professors, about our courses, whatever we're keeping information about, data in our database about, we should have attributes for those things. We need to have, every person should have a name, or possibly an email address, or a phone number, those kinds of things. Here, we've talked about it plenty of times before, you have a student number. That's your primary key. All of you, as far as I know, all of you should have a TJ Kimlik number, right? And so that's something that we might keep in our database. Okay. Attribute domains. One of the things we're going to do during the conceptual phase is we're going to discuss the domains of an attribute. What types of data? Remember, domain is not just the set of allowable values, that's part of it, but it's also just the type of data. So if I'm keeping information about an employee's salary, for example, what type of data is that? Hopefully all of you would recognize that as a number attribute. That is a numerical type, and it might have a range, right? So we might say, okay, their salary should be greater than, if we're thinking about a year salary, should be greater than so much. Like for thinking Turkish lira, I'm thinking of for keeping track of their salary should be at least a couple thousand, I would imagine. I mean, be kind of low, right? But there could be a maximum as well, is that we might have for a certain position or a certain type of organization, we don't ever want someone to be able to put in a value that's greater than a certain amount. Those would be the kind of things that we would talk about in terms of domains. Candidate, primary, and alternate key attributes. We won't talk in depth about that. You just remember that the candidate key and the primary key is a chosen candidate key. A candidate key is just something that's unique that can identify a row, and that no subset can identify that row. All right. That would be a candidate key. All right. The enhanced modeling techniques, right? We talked about that. This is an optional step because we don't have to use this. There's no requirement